Hi all, welcome back to another session of Chem Tutor. In this session, I am discussing about the multiple choice question related to the topic, that is heterocyclic compounds, amines, cyanide and isocyanides. To the first question, that is, which of the following is not true about the 5-membered rings? A option is 5-membered rings are more stable than 4-membered rings. B option is 5-membered rings are more stable than 6-membered rings. C option is 5-membered rings are more stable than 7-membered ring. D option is 5-membered rings are more stable than 8-membered rings. So when we come to the option B, that is 5-membered ring and 6-membered ring. Actually, 6-membered ring have 3D conformation, that is chair conformations and board conformations. So these conformations relaxes their angles and come closer to the tetrahedral bond angles, so that they have more stability than that of the 5-membered rings. So 6-membered ring will be more stable when compared to the 5-membered ring. So the option B is incorrect, that is 6-membered rings are more stable than 5-membered rings, not the 5-membered rings are not stable than the 6-membered ring. Second question, that is, which of the following 5-membered ring is more resonance stabilized? A option is furan, B option is thiophene, C option is pyrrole, D option is all have same resonance energy. So when we look the resonance energy, that is furan is having only resonance energy of 15.9 kilocalorie per mole. But in the case of a thiophene, it is about 29 kilocalorie per mole and pyrrole is having 21.2 kilocalorie per mole. So out of this, thiophene is having high resonance energy. That means it is more resonance stabilized and more aromatic in nature. So option B is correct. So coming to the third question, that is, what is the product when thiophene react with bromine in benzene? A option is 2-bromothiophene, B option is 3-bromothiophene, C option is 2,5-dibromothiophene and D option is 3,4-dibromothiophene. So when thiophene is undergoing bromination or electrophilic substitution reaction, most favorable position will be second and the fifth position. So thiophene undergo brominations means we will get 2,5-dibromothiophene. So option C is correct. So coming to the fourth question, that is, what will be the reagent used for the completion of the reactions? It is pyrrole on treatment with which reagent gives its trimer. So option A is concentrated acid, B is dilute acid, C is concentrated base, D is dilute base. So in a brief time, when pyrrole is treated with dilute acid, there is a tendency to form trimer. So option B is correct, that is dilute acid. The fifth question, that is, which statement about thiophene is incorrect? A option is oxidative polymerizations of thiophene lead to a conducting polymer. B option is thiophene is polar. C option is thiophene is more reactive towards electrophiles than furan. D option is the sulfur atom contributes 2 electrons to the pi system. So out of this option, when compared to the electrophilic substitution reactions of thiophene and furan, we found that thiophene is having more resonance energy. That means it is more stable than that of the furan. So it will be less reactive towards the electrophilic substitution reactions. So option C is incorrect. That is, thiophene will be more reactive than the towards electrophiles than furan is incorrect option. Actually, furan will be more reactive towards the electrophiles. To the sixth question, that is, pyrrole is less basic than pyridine. The orbital having the lone pair of electrons on nitrogen in pyrrole is A is s orbital, B is p orbital, C is sp2 orbital and D is sp3 hybridized orbital. So we all know that pyrrole is having a 5-membered ring with carbon and a nitrogen atom. And moreover, the lone pair electron present in the nitrogen atom is participating in the delocalizations of the pi electron, and thereby the nitrogen this lone pair electron is present in the sp2 hybridized orbital. So the orbital, that is lone pair of electron on nitrogen atom is present in the sp2 orbital. So option C is correct. So coming to the seventh question, that is heterocyclic diene employed in cycloaddition reaction is A option is furan, B option is pyrrole, C option is 2,5-dimethyl pyrrole, D option is thiophene. So out of these four options, that is furan is having a low resonance energy and it is more reactive and it has a capacity to act as a diene towards the cycloaddition reactions. So A option is correct, that is furan is employed in the cycloaddition reaction as a diene. Coming to the eighth question, that is decreasing order of reactivity of the following compounds towards electrophile is. Compound 1 is pyrrole, compound 2 is thiophene, compound 3 is pyridine. So A option is second is greater than, first is greater than third. So B, second greater than, third greater than first. That is a B option. C option is third greater than, first greater than second. And D option is first greater than, second greater than third. So out of these three heterocycle, that is pyrrole, thiophene and pyridine. So pyrrole is having less resonance energy when compared to the thiophene and the pyridine. And again nitrogen is having a lone pair electron and moreover that nitrogen is attached to the hydrogen atom. So when compared to the pyrrole and the pyridine, resonance stabilization is less for pyrrole. So it will be more active towards the electrophiles. And again when compared to the pyrrole and thiophene, pyrrole is more reactive than that of the thiophene because nitrogen size is less. Moreover, nitrogen is trivalent in nature, so more capacity to donate electron towards the delocalization is also higher. So pyrrole will be more reactive towards the electrophile than that of the thiophene. So the option D will be correct, that is first is greater than second, greater than third. That is pyrrole is having high reactivity towards the electrophile, then comes the thiophene, then comes the pyridine. So coming to the ninth question, that is what is the name of the following reactions? That is pyrrole on reaction with chloroform in the presence of potassium hydroxide giving pyrrole to aldehyde. So A option is Gattermann reaction, B option is Riemer-Tayman reaction, C option is Friedel-Crafts reactions, D option is Blanc's chloromethylations. So actually this reaction is a Riemer-Tayman reactions. So pyrrole has a capacity to undergo Riemer-Tayman reaction just like that of a phenol. So what is Riemer-Tayman reaction is that when any electron-rich compound react with chloroform in the presence of potassium hydroxide or in presence of a base, there is a chance to form an aldehyde at the second position of that electron-rich compound. So the reaction is actually Riemer-Tayman reaction, so option B is correct. So coming to the 10th question, that is nitrations of pyrrole is best carried out using A option nitric acid, B option acetyl nitrate, C option is concentrated nitric acid and sulfuric acid, D option is ammonium nitrate. So usually nitrations of pyrrole is best carried out using acetyl nitrate, so option B is correct. Coming to the 11th question, that is major product 70% to 80% of the reaction between meta-dinitobenzene with ammonium bisulfide, that is NH4HS, is A option is meta-nitrobenzene, B option is 3-amino 5-nitrobenzene thiol, C option is meta-nitroaniline, D option is 3,5-diamino-benzene thiol. So in this case we are getting 2 nitro group at the benzene ring. Suppose if you are having 2 nitro group at the benzene ring and if you want to reduce one of the nitro group to amine and keeping other nitro group unaffected, we are using the reagent ammonium bisulfide. So when meta-dinitobenzene is treated with ammonium bisulfide, one of the nitro group get reduced to amine and other nitro group will remain unaffected. So option C is correct, that is meta-nitroaniline is the answer. Coming to the next question, that is on reduction, secondary amine is given by A option nitrobenzene, B is methyl cyanide, C option is nitroethane, D option is methyl isocyanate. So we all know that methyl isocyanate, that is CH3 NC on reduction we are getting a secondary amine. But when methyl cyanide, that is CH3CN, is undergoing reduction means we are getting a primary amine. Similarly, nitrobenzene on undergoing reduction we are getting aniline, and nitroethane also undergoing reduction we are getting ethanamine. So the option D is correct, that is methyl isocyanate. So coming to the next question, that is acetamide and ethylamine can be distinguished by A option is aqueous HCl and heat, B option is aqueous NaOH and heat, C option is acidified KMnO4, D option is bromine water. So here when we look the option B, that is aqueous NaOH and heat, we can distinguish acetamide and ethylamine, because when acetamide is treated with NaOH, aqueous NaOH, we are getting sodium salt of acetic acid and ammonia will be released. But when ethylamine is treated with aqueous NaOH and heat, there will be no reactions. So we can distinguish acetamide and ethylamine by using aqueous NaOH and heat. So option B is correct. Coming to the last question, that is an organic compound A having molecular formula C2H3N on reduction gave another compound B, and B upon treatment with nitrous acid gave ethyl alcohol, and again same B on warming with chloroform and alcoholic potassium hydroxide, it formed an offensive smelling compound C. The compound C is A option is CH3CH2NH2, B option is CH3CH2NC, C option is CH3CN, D option is CH3CH2OH. So when we look the molecular formula, that is A molecular formula, that is C2H3N. So on reduction it gives a compound B, and that B can react with nitrous acid means B should be an amine. So first it should be reduced to amine, that is C2H3N should be reduced to amine means first it can be cyanide. Cyanide on reduction only it can give an amine, and that too a primary amine should be obtained. Then only it can react with nitrous acid to give alcohol. So first the compound can be C2H3N can be a cyanide, that can be methyl cyanide, that is CH3Cn. Then on reduction it can give CH3CH2NH2. So after getting the B, it can react with nitrous acid to give CH3CH2OH. So again the same B, that is CH3CH2NH2, can react with chloroform, because any primary amine can react with chloroform and alcoholic potassium to give the isocyanate. That reaction is termed as a carbonamine reactions. So the compound C should be isocyanate, because first the CH3CH2NH2 is treated with chloroform and alcoholic potassium hydroxide means it is a carbonamine reactions, and there is a formation of a isocyanate. So the compound will be CH3CH2NC. So option B is correct. So that is all in this session. Hope you like this session. Stay tuned for the next session. Till then, bye.